All right, good morning, everybody. We're going to take a look at the new Unit 10 Part 2 packet. First lesson coming up, Introduction to Rational Functions. So let's take a look at the first couple pages here. All right, so Introduction to Rational Functions. Rational functions are simply the ratio of polynomial functions. All that means is they're basically fractions. Okay, a ratio is a fraction. Where in the numerator we have a polynomial, x raised to some powers. In the denominator, we have a polynomial, x raised to some powers. And again, it's going to be whole number powers when we talk about polynomials, okay? So if you look down here at the first example, we're going to be looking at, we have a linear polynomial in the numerator and a linear polynomial in the denominator. Down here at the next example, we have a linear polynomial in the numerator and a quadratic polynomial in the denominator. In any event, these types of fractions are known as polynomials, or excuse me, rational functions. Okay, these types of fractions are known as rational functions. Okay, so we're going to take a look at the algebra of this stuff. Let's take a look at exercise 1. Consider the rational function given by f of x equals x plus 6 all over x minus 3. Algebraically determine the y-intercept for this function. So again, when we cross the y-axis, what do we know? We know that x equals 0. Okay, so let's look at f of 0 here and see what we get. Just plug 0 in for x. And it looks like the y-intercept is at -2. Okay, part B, algebraically determine the x-intercept. Oh, well, that's when we cross the x-axis. That's when y is 0, right? Hint, a fraction can only equal 0 if its numerator is 0. Well, let's see where that comes into play. So if I let y equal 0, that's our f of x. So we're going to let that equal 0, and we're going to solve for x now. Okay, well, we do have a fraction that's equal to 0, and as the hint says, a fraction is 0 when the numerator is 0. So we're going to take the numerator and set that equal to 0, and solving for x is -6. Okay, so the x-intercept is at -6. Okay, in terms of a coordinate, we have that. Over here, we would have 0, -2. Okay. Part C, for what value of x is this function undefined? Why is it undefined? Okay, so a function is undefined when you have 0 in the denominator. Okay, so this thing, make that a little neater, this x plus 6 over x minus 3 is undefined when the denominator is 0. So that's when x minus 3 is 0, or when x equals 3. Okay, so that's the only value that we can't plug into this function. If we try to plug 3 in, we get 9 over 0. That's undefined. Now, part D, it says, based on part C, state the domain of this function in set builder notation. So basically, we figured out that 3 is the only value that's no good. So one way we could write this in set builder, all x such that if it can't be 3, we can say x is less than the 3 or x is greater than 3. And that's one way that we could do it. Now we can do it even more efficiently like this. We could say, look, all x such that x does not equal 3. All right, and that's the same thing. And you'll see that in some of the examples later, okay? But that's the idea. So when we're talking about the domain of these things, it's okay to plug any value of x in except values of x that make the denominator 0. That's the gist. All right, let's move on to the next example. Number 2. Find all values of x for which the rational function given by h of x equals x plus 5 over 2x squared plus 11x minus 6 is undefined. Verify by using your calculator to evaluate this expression for these values. Okay, so again, we're interested in when this thing is undefined, which means we're interested when the denominator equals 0. Okay, so this time we have a quadratic. Let's factor it. I'm going to use the a times c method here. So that's -12. And let's see, I need factors of -12 that add up to 11. So that's going to be +12 and -1. Okay, those multiply to -12 and they add up to 11. So let's say I'm going to break this up. 2x squared plus 12x minus 1x minus 6. and I'll factor by grouping. First group has a GCF of 2x, and the second a GCF of -1, okay? So watch out for that, and again, we'll get an x plus 6 in our parenthesis. Okay, so factoring 2x minus 1 times x plus 6. Okay, so we're either going to get x is -6, or we end up with +1/2, okay? So those are the two values that will make this function undefined, okay? Now checking on the calculator, if I plug carefully 1/2 in for x into this thing, or I plug -6 in, you should get an error message back on your calculator, and that's an indication that it's undefined, okay? All right, number 3, which of the following represents the domain of this function? Okay, so this is kind of like part D up above in example 1. We're going to set the denominator equal to 0, and then those are the values that we exclude from the domain. And you can see how they've written their answer choices here, similar to like what I did above. All right, so let's say undefined when the denominator equals 0. Okay, this we can factor. We need numbers that multiply to -16 and add to -6. So I think we're looking at -8 and +2 here. And this equals 0 when x is either 8 or -2. So in terms of the domain, x can be any number except for those. So that's choice 3. Okay, next up. If g of x equals 3x minus 2 and f of x equals 2x plus 1 over x plus 5, then find. Okay, so g of x is a linear function. F of x is our rational function here. Okay, let's see what we get here. So we're doing some compositions. In part A, we want f of g of -2. So let's look at g of -2 first. And plugging that into the g function, -6 minus 2 is -8. Now we'll plug that into the f function. So f of -8, 2 times -8 plus 1 over -8 plus 5. Let's see, we're looking at -16 plus 1 is -15. -8 plus 5 is -3. So that's going to equal 5. Okay, so there we go for that part of the problem. Final answer 5. Okay, part B. Let's do g of 2 first, because that's inside. That's 6 minus 2 is 4. Now we'll look at f of 4. And it looks like we get 9 over 9 is 1. Okay, so here f of g of 2 is 1. And lastly, let's find f of g of x. Okay, so g of x in and of itself is 3x minus 2. F of g of x is then going to be f of 3x minus 2. So up in the f equation, I'm going to replace the letter x with 3x minus 2 wherever I see it. Okay, so we're going to have 2 times 3x minus 2 plus the 1 over 3x minus 2 plus the 5. Once again, I just replaced the letter x with 3x minus 2 to do that. All right, let's clean it up. Up top, distributing 6x minus 4 plus the 1. Down below, 3x, -2 plus 5 is plus 3. All right, -4 plus 1 on top is -3. 6x minus 3 over 3x plus 3. And let's see, can we simplify? I think so. We can factor a 3 out. Okay, and so at the end of the day, in its nicest, neatest form, 2x minus 1 over x plus 1. Okay, number 5. Find the formulas for the inverse of each of the following simple rational functions below. Recall that as a first step, switch the roles of x and y. Okay, so we're going to find the inverses, so we'll flip x and y. So this becomes x equals y over y minus 2. I just flip-flop. Whatever was y becomes x, whatever was x becomes y. Now the idea is to try and get the letter y by itself in terms of x, okay? So here's what we want to do. We want to get the y minus 2 out of the denominator. So I'm going to multiply both sides by y minus 2. Those are going to cancel on the right. Okay, so over here we have y minus 2 times x equals y. Let's distribute the x. We're going to get xy minus 2x equal to y. Now, anything with a y in it, I want on one side of the equation. Anything without the letter y, I want on the other. So I'm actually going to move this xy over to the right with the other y. So I'm going to subtract that. So when I do that, we get negative 2x equals y minus xy. All right. Now, what I'm going to do is I can now factor the y out of the right-hand side. All right. So let's come up here. We're going to have negative 2x equals y times 1 minus x. Now all I have to do to get the letter y all by itself in terms of x is divide by the 1 minus x. Okay, and so what do we have here? We get y equals negative 2x over 1 minus x. And there's our inverse. All right, let's try it again with part B. Okay, so again, to find the inverse, I'm going to switch x and y in the equation. Let's multiply the 2y out of the denominator. So I have, I'm going to write it like this, 2xy equals y plus 3. So again, we just multiplied the 2y out of the denominator. Now I want to get all the y stuff together. So I'm going to subtract the y on the right to the left. So we're going to have 2xy minus y equals the 3. Now I can factor out the y, and now I can divide to get y by itself. All right, and there's our inverse rational function. Okay, so practice that a little bit if you need to. Not too uncommon for those to show up on the Regents, assuming we're still going to see that. And last exercise for the lesson, the function f of x equals x squared minus 8 over 4x is either an even or an odd function. Determine which it is and justify. Based on your answer, what type of symmetry must this function have? Use your calculator to sketch a graph to verify. Okay, so even functions have symmetry over the y-axis. And if you replace x with its negative, you get the same y value back. Odd functions are symmetric over the origin. If you replace x with its negative, you get the negative of your original y value back. All right. So what we could do to determine if this is even or odd is just we could plug in opposite values of x and see what we get. Now, first thing to note is that this is undefined at 0. So there's nothing at 0, right? Plug in 0, it's undefined. But let's look at f of negative 1 and let's look at f of positive 1. If those y values are the same, then what we have is an even function. If those y values are opposites, then we have an odd function. All right. So plugging negative 1 in, we're going to get negative 1 squared minus 8 over 4 times negative 1. So here we have 1 minus 8, negative 7 over negative 4 is 7/4. When I plug positive 1 in, well, we're going to end up with the same value in the numerator, but we get a positive 4 in the denominator. Since f of 1 is equal to the negative of f of negative 1. All this means is when I plugged in opposite x values, I got back negative and opposite y values. Since these are opposites, f of x is an odd function and has origin symmetry. Okay, and then if we take a second to look at the graph of this thing, just punch it in carefully. Let's see what we get here. Okay, make sure your window matches up. And we're looking at something like this. where it shoots up, and then it comes down from below, and certainly is a reflection over the origin here. Has the origin symmetry. Opposite x's give opposite y's. And again, this is undefined at x equals 0, so we got an asymptote here. The graph will never touch that. It's undefined at 0. Okay, so give the homework a try and then check your solutions. Have a good day.